To understand the trapezium rule, I'm going to take you back to 50 BC in ancient Babylon. Basically, these cavemen motherfuckers were looking up at the sky and they realised that there's this star called Jupiter that was moving across the sky at a certain velocity. They measured this velocity and they plotted it on like a graph on some rock in a cave somewhere, and they realised that if they find the area under the graph of the velocity curve, then they can get displacement. But integration hadn't been invented yet. In fact, Isaac Newton didn't even invent gravity at this point, so I don't know why they didn't just jump up and have a look for themselves. So anyway, a Gigachad Sigma male caveman comes up to him and breaks his 3-hour-long mewing session and asks him, "Have you tried the trapezium rule?" The trapezium rule? What's that, they said. So if I was a beta male, then I'd say the area is the integral of f of x. But I'm not a beta male, I'm an alpha male, so instead what I'm going to do is I'm going to split it up into 4 different trapeziums. Then I'm going to calculate the area of each of these trapeziums. So this first trapezium here has a base of 2, and the top is 1, and the height is 1. So to calculate the area of a trapezium, we do a plus b over 2 times h, which in this case is 1 plus 2 over 2 times by 1, which gives us 3 over 2. The second trapezium is exactly the same, so that's also 3 over 2. The third trapezium is a bit different. It's got a base of 5, the top is 2, and the height is 1. So we're going to have 5 plus 2 over 2 times by 1, which is 7 over 2. And finally, the last trapezium is 10 plus 5 over 2 times 1, which is 15 over 2. To get the final area of underneath the curve, we've got 3 over 2 plus 3 over 2 plus 7 over 2 plus 15 over 2, which gives us 14. The actual area turns out to be 13.3 recurring, so with just 4 trapeziums, we've actually only got a 5% difference. But you're not always going to be dealing with whole number answers. Life is never that simple. Okay, little things might crop up. Your wife might divorce you. She might take the kids. Your son might chop his dick off and identify as a woman. Little things are going to crop up and you've just got to deal with them as they come. So in this example, I'm going to use algebra instead of using the numbers because the numbers are quite horrible. It's horrible decimal numbers. So I'm going to start by marking out my boundaries from A to B. Okay, and then I'm going to split this up into 1, 2, 3, 4 trapeziums. Okay. Now, I'm going to call this first one y1. I'll call this first one here y0. That's the 0, 0 marker. This one's going to be y1. This line's going to be y2. This line's going to be y3. And this line's going to be y4. Now, the way that we split up the trapeziums is always going to have the same change in x, or in this case, I'm actually going to call it h, because we're going to do the height of the trapezium. This stays the same for all of the trapezium. So same as before, I'm going to calculate the area as the first trapezium. We've got y0, which is just nothing, and then we've got the height, which is the same. So we end up with a half of the height times by y0 plus y1. Now, this second trapezium, I'm going to do the same thing, but this time y2 is actually smaller than y1, so it's going to be drawn like this. In the third trapezium, it's half the height times y2 plus y3. Now, you should be seeing a pattern. In the fourth trapezium, I'm not going to draw it out. It's half the height times y3 plus y4. So to get the total area, I'm going to add all of these together. But to make it a little bit simpler, I'm going to factor out the half h, because that is the common term in all of these. So we're going to factor out the half h, and then we end up with y0 plus y1, and then we've got another y1 here, so there's 2 y1s, and then we've got 2 y2s, and then we've got 2 y3s, and then just a single y4 on its own. So the area is half the height times y0 plus y4 plus 2 lots of y1 plus y2 plus y3. There is a way to generalize this for n number of trapeziums, and that is half the height times y0 plus yn plus 2 lots of y1 plus y2 plus y ... You get the idea, right? Plus y to the n, y of n minus 1. Okay, so this is what I like to call a sandwich, right? So we've got the y0 and the yn making the bread of the sandwich, and then on the inside we've got the 2 lots of y1 plus y2 all the way to yn minus 1. Now, if you scroll down and click the top link in the description, I've actually made a little tool for you to use on Desmos where you can type in your own function and change the number of trapeziums and see how close your integral gets to the actual answer. And you can change the limits and everything, so it's a cool little tool. Try it out for yourself if you want to see the trapezium rule in action. Till next time, peace.